All right, one more example of adding polynomials in columns for section 7.1. This one we're going to be doing both an addition, changing subtraction to addition, and then the ordering of a polynomial that has a missing degree term. So I'm going to say plus a -1 times, and then I'm going to distribute this through the second polynomial here. So I'll get a negative there, a negative there, and a positive there. So I'm going to rewrite that as a negative x squared, and then minus a 2x, and then plus 3. And now I'm going to order this by leaving the space in the middle because I'm missing an x degree term, an f first degree term. So I have an x squared, and then plus, I'm just going to leave the blank, minus 9 over here underneath the constant. I'm always adding. 3 plus -9, which is a -6. 9 minus 3 is 6, and it's negative. And then -2 plus 0 is a -2x. And then negative x squared, and x squared is 0. When it's 0, I don't write anything. Don't write 0x or x squared or anything. Just write nothing. And so -2x minus 6. And some of you might know factoring. Don't be tempted. We're not factoring yet, so don't do that. Right, now we're on to our next topic, which is evaluating algebraic expressions by using our function notation. So finding the value of a polynomial function is what we're saying this time, instead of evaluating an algebraic expression. So we're going to combine our two topics. So we're going to leave blanks for wherever the variable is, and then whatever's in here, right, that's our x, we're going to substitute that in for the x's here and here. So if f of x is equal to x squared minus 3x plus 3, finding the value of f of -1, that means f of -1 is equal to, we see whatever our x is going to get squared, so I put the -1 in there, minus 3 times whatever x is, so I put the -1 in there, and then plus 3. And then I simplify, and this one says a -1 times a -1. And negative times a negative is a positive, and that's 1. And negative times a negative is a positive. 3 times 1 is 3. And so now we see that this simplifies as 1 plus 3 plus 3. So we have 1 plus 3 is 4, and 4 plus 3 is 7. And so f of -1 is equal to 7. And that is evaluating a polynomial function. Nothing different than evaluating an algebraic expression. Now let's do it for our next one, g of x. So g of x this time looks like x squared minus 5 quantity squared, and we're going to find g of 4. So what this means is that we're going to have to upgrade our parentheses that already exist here to brackets so that I can put a parenthesis in for the x, quantity squared. Well, the x is 4, so I'll put that in. Minus 5 in brackets, and then squared. So this says 4 times 4, and 4 times 4 is 16, and then 16 minus 5, and that's going to get squared. So 16 minus 5 is 11, and 11 gets squared. 11 times 11 is 121, and that's our final answer. So g of 4 is equal to 121. And that's evaluating a polynomial function. Our next topic is to talk about how we can add or subtract polynomials using function notation. Now, some books call this the algebra of functions, and all we're really doing is exactly what we were doing before, where we added or subtracted two polynomials, which is just simplifying algebraic expressions. So we're going to see how looking at the left side of this expression is exactly like looking at the right side of the expression. So I'm going to take it very literally, and I'm going to take the left side to say, okay, f of x plus g of x, add two polynomial functions, as opposed to add the two functions in general to come up with a new function and then evaluate them. So we're going to do this by evaluating, and you'll see how this goes in the next section. And this isn't because you have to take them literally, it's just to show you that they give you the exact same values, so you can take it as you need it to be whenever you see this algebra of functions.